to my lecture today. Today we are actually starting a new chapter, chapter 6. And this is actually called continuous probability distributions. Of course, you remember last week, I walked you through probability distribution of a discrete type. Now, let me tell you this. If we were to solve probability problem, it could be probability problem in business, probability problem in medicine, politics, and so on like that. Of course, we need to be able to identify the probability distribution of the data set. And I could remember last week, I walked you through different probability distribution when the random variable is discrete. And the focus today, the focus this week, is when the random variable is continuous. When the random variable is continuous, we have different kinds of probability distribution. We have what we call normal distribution. We have exponential distribution. We have gamma distribution. We have Weibull distribution and the beta distribution. Okay. Let me first, before I get started today, I actually, maybe I'm going to say I was under the heads on Saturday, and probably I was not able to respond to call, but I'm fine now. Okay. I just want you to know that I'm fine now. Okay. So, the focus today will be on normal distribution. And I'm going to give you history about normal distribution. Normal distribution is actually a probability distribution that approximates natural phenomena. Most of the natural phenomena, can actually, be approximated by normal distribution. When I say natural phenomena, I'm actually going to walk you through each of that. But before I go into that, I'm also going to let you know today, the outline is basically going to be, how do we calculate probability for normal distribution? How do we calculate probability for normal distributions? Before you can actually calculate probability for normal distributions, you need to first investigate whether the distribution of your data set is normal. I'm going to say that again. When you are working with a continuous random variable, we have a way to investigate the nature of the probability distribution. And that can actually be done using an histogram. There's a plot called histogram. Okay, that will enable us to know if the distribution of the data set is normal or not. Now, I want to tell you today, when you talk about normal distribution, of course, it is actually a symmetrical arrangement of data set. Symmetrical arrangement of data set. And that is actually what we mean by that. I'm going to go through an example now. I'm going to show you the shape of a normal distribution. When you take a look at what I'm displaying right now, initially I did not include this in the data set. I mean, in the lecture slide, but I'm going to, update that. Okay, now take a look at what I'm trying to show you now. When you are talking about normal distribution, we want to use normal distribution to explain some factors in the population. And before we can actually use normal distribution, we need two parameters. And what are the parameters? Mean and standard deviation. I'm going to say that again. If we want to use normal distribution, we need two parameters. And the two parameters are actually mean and the standard deviation. And mean is the center. It's going to be the center of the distribution, as you can see right here, mu. This is basically the center. And let me tell you this, the deviation away from the center, is actually measured by the number of standard deviation. I'm going to say that again. The deviation away from the center is actually measured by the number of standard deviation. When you take a look at this area, okay, this is one standard deviation within the center. One standard deviation within the center. Actually, if you take a look at this guy here, mu plus sigma is one standard deviation above the mean, and mu minus sigma, one standard deviation below the mean. And when you look at that area, this area, it's actually one standard deviation within the center, within the mean. And you know, we've proved that the percentage of the observations that are within one standard deviation from the mean is about 68%. That's why when you add 34.13 to 34.13, that will be 68%. And within two standard deviation, about 95%, and within three standard deviation, about 99.75%. Now, there's something I'm actually going to show you. You know, some of you may be wondering, why are we actually, how do we know? Okay, how do we know that? I'm actually going to show you now. Okay, when X follows normal distribution, okay, when X follows normal distribution with mean mu and standard deviation that f of X equal 1 divided by 2 pi sigma squared exponential raised to power minus half X minus mu over sigma all squared. You know, when you take a look at this, this is a probability function that I'm actually going to call probability density of a normal distribution. Of course, the range of X, okay, the range of X is actually between negative infinity and positive infinity. It means when I integrate this from negative infinity to infinity, the total area under a curve has to be 1. Now, if I actually want to consider within one standard deviation, so which means I want to go from mu minus sigma to mu plus sigma, okay, of 1 divided by 2 pi sigma squared exponential raised to power that X minus mu over sigma squared, okay, ds, okay, the result is going to be 0.68. We know that it is 68% because when you integrate this from mu minus sigma to mu plus sigma, of course, that will give us 0.68. This is a mathematical way to be able to figure that out. Okay, you know, but if I actually go from, if it is within 2 standard deviation, then what you're going to get will be different. So what you're going to get will be 0.95. So what you're going to get will be 0.95 that we actually call 95%. Okay. And when you change that again, or probably to 3 sigma and 3 sigma, and this is actually going to be 0.9975. And that is where we got 99.75%. And I'm actually going to call that empirical rule. You remember the other time when I was walking you through Chebyshev inequality? I remember I told you empirical rule applies to normal distribution, and the Chebyshev inequality actually apply to, situation where the data do not, the distribution of the data does not follow normal. Okay, so this is empirical rule, and this is how we are able to get that. Okay, now normal distribution is a very good distribution for technical stock returns. Okay, For technical stock returns, what I'm trying to show you now is S&P 500 of percent return versus normal distribution prediction. I want to tell you, because we live in a probabilistic world, and the stock, there's a volatility in the stock market. Of course, if you actually want to determine probability of some of returns, of course, you can actually use normal distribution. Another example, normal distribution is a very good distribution for income. Okay, the income distribution in a population, when you look at the center, when you look at the normal distribution, you're actually going to see, like, we have middle class to the left of the middle class, okay, and to the right of the middle class. Okay, so to tell you that normal distribution is actually a very good probability distribution to model income distribution. And not only income distribution, I want to tell you in medicine, okay, we use probability distribution to, it's a very good, normal distribution is a very good probability distribution for blood pressure. Okay, for blood pressure, for instance, if I know the average of blood pressure for normal human being, what is the probability that the value, the blood pressure for my patient will be less than a particular value? What is the probability that is going to be greater than a particular value? What is the probability that is actually going to lie between, something and something? Okay, then another example that I'm displaying now is a female shoe sales. Okay, the female shoe sales actually follow normal distribution. Okay, but let me tell you this. We actually want, if we want to find probability using normal distribution, what do we need to do? What we actually need to do, we're actually going to make conversion. Okay, we're actually going to convert the original score to a standardized score. I'm going to say that again. If we want to find probability, okay, using the normal density, okay, you're actually going to convert the original score to a standardized score. And you know what, before you can do that at all, okay, you have to be provided two parameters of a normal distribution. And the two parameters of a normal distribution is actually the mean and the standard deviation. They have to be given. Okay, now I want to put it to you now. They have four problems. We have four different basic probability problems that we can actually figure out using a normal probability distribution. I'm going to say that again. They have four, okay, different problems that can actually be used, okay, that we can actually, figure out using normal distribution. I'm going to tell you, number one is, if I want to find the probability that a random variable will be less than some value, less than. Another one, I may want to find the probability that is going to be greater than. Another one, I may want to find the probability that it lies between. That is number three. And number four, I may want to find the probability that it is less than one value, but greater than the other one. Okay, these are the four different scenarios, okay, that you can actually use the normal density for. Now, I'm going to walk you through an example on each of these, and I'm going to walk you through how you can implement this using a statistical table, and not only that, using calculator, okay, T18384, and using the R software. Okay, for those of you who want to use our software, I told you attendance of the lab is not compulsory, but attending the lab, if you want to use the idea of the lab, either in exam or assignment, of course, that is acceptable, because I just provided that as an option to reflect reality. Okay, now I want to go into an example now. There's an example of a less than. It said body temperatures of adults are normally distributed. Look at that. They've already found out. In exam, an examiner will actually tell you, if I want to ask a question on normal distribution, of course, I'm going to tell you that it is normally distributed or no. Now, as we can look at this question, it said, the body temperatures of adults are normally distributed with a mean of 98.60 degree and a standard deviation of 0.73. Now, when you take a look at this question, you have already been provided with the two parameters. Now, the question now is, what is the probability of a healthy adult having a temperature less than 96.9? This is a question on less than. Now, mathematically speaking, this is what you want to find the probability of S less than 96.9. And what did I ask you to do? When you are given an original score, you need to convert to the standardized score. The formula for the standardized score is Z equal S minus mu over sigma. Let me just use this opportunity to tell where you are in my class. I want to tell you I need you to be focused because I notice some people, they are in the class and they're doing something else. I don't want you to postpone your understanding. You can actually understand right why you are here. Okay, please, what I just need from you is you stay focused. And I know some of you have tutors. When you stay more focused, I want to tell you, you can also act as tutors to somebody. You know that? So you can, what I just need from you, you just sit down. I'm actually going to explain. You understand what I mean? Trust me. So just you focus on the board, and the moment you don't understand, please let me know. Now, this is the next step here is to standardize. And what is the formula for standardization? It is X minus mu over standard deviation. The mu here is the mean. The sigma represents the standard deviation, and the X is the question, because that is the S. So after converting that, what does that give? Minus 2.33. Minus 2.33, it is no longer the original score, but a standardized score. Now, what we want to do now, initially, when you take a look at the shape right here, this is a normal distribution for the data. Okay, where this, the mean, the center is 98.6. And of course, what do you want to find? You want to find the probability that is going to be less than 96.9, which is to the left. Now that you've gotten the z-score of that, you're no longer working with this anymore, but you are still working with normal distribution, only that the center is now 0. After standardization, the center is going to be 0. Okay, that is why you have 0. Okay, and you know what? If I want to find the probability of X less than this, then this is what I'm going to find now is the probability that Z less than this. That is what I'm going to find. And that was why I said the probability of X less than that, it is the same as the probability of Z less than minus 2.33. Or what you're just going to do, you take a Z table that I'm actually going to allow in exam. In fact, I'm going to provide in exam. Okay. Yeah, I'm going to check under the Z table. I'm going to check minus 2.3 under 3. And that will give me this. For those of you who are actually using R, okay, for those of you attending the lab, if you want to get the probability of, something less than the Z, less than minus 2.33, it is just a simple code, okay, that I'm actually going to write now. And the simple code, the probability of Z less than minus 2.33 is basically P norm of minus 2.33. Whatever you get is the result. When you write P norm of minus 2.33, it will automatically give you that result automatically. Okay. Now, if you actually want to use a calculator, which I'm also going to allow, particularly if you have T18384 calculator, do you know you can also use that to figure out how the value of minus 2.33 less than minus 2.33. This is the way the calculator, you just need to enter normal CDF, okay? And you're going to put like a minus, this is like more or less like a minus infinity. Okay, then you're going to put 96.9, okay? And you're going to put the mean, you're going to put a standard deviation. I want to tell you automatically, the calculator will give you that result. There's so many options that I've provided today. Now, I want to go into another example this time around. It's an example on greater than. We've looked at the example on less than. Okay, go ahead. Yeah, you know, it was negative minus 2.33. You're going to check statistical table. You know, when you look at the Z table, statistical table, is from negative to positive. You're always going to see minus 2.3 under 3. So minus 2.3 in this column, under 3, you just need to read the corresponding probability value, and you're actually automatically going to get what you have here. Automatically, you're going to get this. Okay, so I'm providing 3 options for you to check. Number 1, using a statistical table. Number 2, using it if you are using that calculator, you follow that. Number 3, if you are attending the lab, P norm of minus 2.33. Any of those options will give the same result. Yeah, go ahead. They are all the same. Exactly. They are all the same. That's a very good question. They are all the same. Okay. Going to the greater than now. This is a question on greater than. If I want to deal with the greater than, I'm going to do the same conversion. Okay. I'm going to get the Z score. But this time around, you know, when you take a look at the first one, greater than 97.6 to the right. Okay, the other one also going to be to the right. The difference now is whatever you check, if you're checking from table, whatever you are checking from table, you will subtract from 1 when you are dealing with to the right. Whatever you check from table, you're going to subtract from 1. If you are using the R software, okay, where you have the greater than or the probability of Z greater than minus 1.37. Okay, now this is the same thing as 1 minus the probability of Z less or equal to minus 1.37. So it's going to be 1 minus P norm. Okay, it's going to be 1 minus P norm. Look at that. Yeah, it's when you are using the lab. 1 if you're using our software. 1 minus P norm indicate you are looking for greater than sign. For less than is just basically going to be P norm. And if you're checking from the table, whatever you check from the table, you're going to subtract from 1. It means what you have in the table is less or equal. Okay. Now, if you want to use the calculator now, okay, the way you're going to enter that in the calculator, it's still going to be normal CDF. You remember when you were dealing with the less than in the calculator, you start from negative infinity, right? For greater than, you are not going to start from negative infinity. Because it is a greater than, you start from the number 97.6 and to infinity, not negative. Look at that, 1E99. That's a positive 1 because you say greater than 97.6. Then you're going to indicate the mean and the standard deviation. Automatically, the result is going to show. Okay, that is how to deal with a greater than. Now, the next one now, how do we do it between? Okay, for between, you know, here you're saying between 98 and 99, between. Okay, so what between actually represents, I'm actually going to write that now for you guys to see. Okay, you know, according to the law, the probability of S lie between A and B is the same thing as the probability of X lie between S less than that minus X less or equal to A. Look at that. So right now, 98, 99, the probability of X lie between 98, 99 will actually be equal to the probability of X less than 99, then minus X less than 98. Okay, take a look at that. On each of these, I'm actually going to get a Z score for each of that. Okay, how many Z score? 2 Z scores. Look at that. Now, what happened now is that this is now going to be equal to the probability of Z less than minus 0.82 and 0.55. Okay, which is basically going to be the probability of Z, okay, less than 0.55 minus the probability of Z less than minus 0.82. If you want to use software, our software is going to be P num 0.55 minus P num minus 0.82. This is where you are using the software. If you're not using the software, if you want to use statistical table, you need to first check 0.55 in the statistical table. You check negative is 0.82 in the statistical table, then you're going to subtract. But what if you want to use a calculator, T18384? Okay, if you want to use a calculator, this is what you're actually going to do. You're just going to write normal CDF. You only need to state the two numbers, the two Z score. The minus is 0.82 and the 0.55. Take a look at that. Normal CDF minus is 0.82, comma is 0.55. You only need to say the two scores, the two Z score. Automatically, that will give you your results. Automatically, we live in a life of choice. You can use a calculator, you can use the software, you can use a table. Whichever one we use, you're still going to get the same result. Now, that is the third one. And I want to go into the fourth one. Let me just revise what I've done. We've been able to use a normal distribution to figure out the probability of a random variable S less than a particular number. We've done that for the probability of S greater than a particular number. We've used that for the probability of S lie in between. But right now, in number 4, we want to find the probability, okay, that a normally distributed random variable will be in the tails defined by 2 given numbers. And, when you take a look at C, you're going to say, is it reasonable at all? Take a look at this. It said, what is the probability of a healthy adult having a body temperature less than 99.6 or greater than 100.6? Look at that. That is not between. You say it is less than a smaller number or bigger than a higher number. You can never call that in between. You know what you're going to do? Instead of subtracting, you're going to add. You are adding. You're going to do what we've been doing. Okay, you're going to find take a look at that. This is what you want to do. Mathematically speaking, the probability of X less than that. Give me 1 second. Let me pull this down. Okay, so you want to find the probability of X less than less than 99.6, and you want to find the probability or X greater than 100.6. Then you're also going to compute 2 Z score because you have 2 original scores. Okay, this guy give you 1.37, this guy give you 2.74, and if you look at the distribution of the original data set, okay, you want to find the probability of S less than less than minus 99.6, and you want to find the probability of S greater than 100.6, and this is now going to be the same as this guy now in terms of the Z score. Now, what are you going to do? What you're going to do, if you want to use the calculator now, okay, if you want to use the calculator now, okay, you're actually going to use the calculator in 2 ways. The first one, normal CDF, starting from infinity, negative infinity to 1.37. Why did you start from negative infinity? Because they say lower than that. You start from negative infinity. Now, if they say greater than that, you start from the number to positive infinity. Look at the second one. This is when you are using the calculator. The calculator is going to give you two results. Now, what are you going to do to the two results? Then you're going to add them together. You're going to do the same when you want to make use of the table. You check for the two in the table, you add. Okay, so you can look at that, then you're going to add that. Okay, that was why I say adding this together. Okay, we have 0.914656 plus that. That is what we actually go for each of that. If you look at the T1 84 83 84 calculator now, adding them, okay, so we are going to have the results. Okay, an alternative calculator method. Okay, this is another way if you want to, if you don't want to, one process in the calculator is to compute them separately. Look at that, one at a time. Another one is you can compute them together by writing 1 minus normal CDF into 99.6, 100.6. Then you specify the standard deviation. I mean, you specify the mean and the standard deviation. You're still going to have the same result. Okay. Now I will quickly go into another example of body temperatures of adults are normally distributed with a mean of 98.6 and a standard deviation of 0.73. What is the probability of any adult having a body temperature differs from the population mean by more than 1 degree? Differs. You know what you're going to do when you hear differ from population mean by 1? You add 1 to the mean, you subtract 1 from the mean to get the two different scores. Now, you're going to do 98.6 minus 1. That will be 97.6. 98.6 plus 1. That will be 99.6. Take a look at this. That was how I got this. Can you see that? 97.6, x less than 97.6 or x greater than 99.6. I got that by subtracting 1 from the mean and adding 1 to the mean. And I'm actually using the idea of example 4 here. Okay, then you're going to convert, find the two different z-scores. Anytime you are dealing with a question like this, differ by 1 or differ by 2, you're actually going to have the same value for the z-score, but only at negative direction. Look at that. This is minus 1.37. That is a positive 1.37. Okay, then you're going to follow the way you've been doing in finding the mean. I mean, checking from the table. Okay, now anytime you have a double, because minus 1.37, 1.37, just check for 1 in the table, then multiply by 2. Look at that. It's 0.053 multiplied by 2 will give you this. And if you want to figure that out, using the calculator, you're just going to write 1 minus normal CDF, 97, the smaller value, the bigger value, the mean, the standard deviation. Automatically, that will give you your result. Look at that. The smaller value, the bigger value, the mean, the standard deviation, and that will give you your result. But don't forget to write 1 minus normal CDA. Okay, now, oh my God, okay, that is the end of today's lecture. The takeaway from today's lecture is this. We actually look at the normal probability distribution that actually give us what I call the symmetrical arrangement of data set. I've given you a different kind of example, and we use this normal distribution to figure out the probability of a random variable is going to be less than or greater than or between or it's going to be less than a smaller number and greater than or greater than a bigger number. I walk you through how you can actually use an R software to figure that out, how you can check from the table, and how you can use a calculator that I call a T1, 83, 84. It's a matter of choice. You can use any of that in exam. Okay, you're still going to get the same results. Okay, so I think by now I've finished with the exam one grading. And for those of you that have extra credit, and if you want to spend that on the exam one, tonight I want to start adding, for those who are interested in adding, um, extra credit to exam one. All what I need from you, tell me the total number of extra credits you have, and I'm actually going to reconcile with the one I have a record, and automatically it will be added to your exam one score. So that is if you actually want to use that for exam one score, but if you don't want to use that, if you are satisfied with what you have for now, you can actually save that for the future exam. Okay, so make sure you guys stay safe and have a good day.
Professor, I have a question on the homework.
Okay, go ahead.
For the 4.89, I think I was trying to find the variance of x, and I wasn't able to find like the expected value of x squared for that one.
Okay, somebody online asked a very good question that has to do with the assignment, and I'm going to say that generally. I just need your attention. Now, I also noticed that in, I think, exercise 4.89, where I asked you to find the variance, the expected value of S squared may be indeterminate, right? If it is indeterminate, I think if I ask you to find a correlation, okay, do you know if you want to find a correlation, you may decide not to get a correlation the moment you are able to investigate if f of xy equal to the product of f of s multiplied by f of y, then you're going to say if x and y are independent, what is going to be the values of correlation? 0. Do you understand now? I know that you're actually going to experience expected value of s squared is going to be indeterminate. What I will advise that you should do is investigate whether x and y are independent. And if x and y are independent, it means from the joint, get f of s, get f of y. If you multiply f of s by f of y and it give you f of xy, then that means x and y are independent. And when x and y are independent, don't do anything again. Conclude that the correlation value will be 0. Does that make sense?
Yes, thank you. I totally forgot to check for that.
You're welcome. Yep. How are you? Oh, when I'm doing now, we're gonna talk. I was under the heads on Saturday. You're gonna talk. What else are you going now? Yep. What? Have any question? Okay. Yeah. Yeah, because of proportions. Look at that. It said, sorry, it said x and y are the proportions of time. So when you say proportions, it's always going to be from 0 to 1. It makes sense, right? Okay.
Thank you.
You're welcome. And have a good day.